Okay, so Dr. Guilherme Rosa is a professor in the Department of Animal and Dairy Sciences at the University of Wisconsin-Madison. His research focuses on developing tools and quantitative genetics and data analytics to enhance the efficiency and sustainability of livestock production systems. His lab specializes in leveraging big data and artificial intelligence to analyze information from multiple sources, including swine. His work includes analyzing farm-level operational data to optimize management practices, developing high-throughput phenotyping methods for real-time monitoring and disease surveillance in individual animals, and advancing techniques in quantitative genetics, genomics, and breeding. His current research projects include applying computer vision in pig production, such as animal identification and the prediction of body weight and carcass traits. Thank you so much, Dr. Guilherme.
Thank you very much. Good morning, everybody. Thank you for the invitation, Igor and Pedro. It's an honor for me to be here. So I was asked to give a brief introduction about artificial intelligence. Isabella gave a very nice overview, so I'll be maybe repeating some of the parts that she presented. And then I'm going to show... Should I close? Let's see if it's better now. Yeah, thank you. And then I'm going to show you some of examples that we did in our lab. So again, just make a brief introduction about this machine learning, artificial intelligence, and then show some examples in pig production. I work across the species in data science. So I'm going to show you some examples with pigs that we have. And then, so my research is mostly in data science. So again, a component, including machine learning, and then, of course, a component of precision livestock farming. But I'm going to show you two main groups of projects, and I'll explain what they are. So artificial intelligence. So it's a field of computer science focused on creating systems that can perform tasks that normally require human intelligence. So Isabella gave already an overview, including where the machine learning and the deep learning sits within the artificial intelligence. And then, like I said, with the data science, we still have this statistical component, experimental design. So it's not all within this artificial intelligence or machine learning group, but it's another component helping with the artificial intelligence. So here's an image that I just created using AI. Okay, so you just say, I want a pig using a smart watch, and then I'm going to Minnesota, put a Green Bay Packers hat, and it creates. Okay, so the types of AI. So there is what we call narrow AI or weak AI. So you build specific tasks. That's what we usually use when you have a GPS. You use Google Maps, Siri, and Alexa. So this is most of the tools that we have. But then we are going towards what we call general AI or strong AI. Some companies say they have already, but that's we are expect to get there, if not, or to be available to us soon. So this is a theoretical AI that could perform any intellectual task a human can do with understanding and reasoning across domains. So I say here, not still achieved, or at least not available to us yet. And then super intelligent AI, where computers will be doing more than all humans together in the world. But narrow AI, that's what we have now, and there are many examples in daily life. So you watch movies, you listen to music, and these tools, they make suggestions to you, and the suggestions are very good, right? So they learn what you like, and especially if you give feedback and you say, I like this, I didn't like, and it improves and learns over time, and it gets better. And then navigation, ride-sharing apps, healthcare, and then the focus of today here is precision farming, so the use of sensors and this data analytics, and then some other very complicated tasks like autonomous vehicles that we have so many companies and so many people working on this. It's not simple, right? So how AI works? Basically, AI is about creating algorithms that can recognize patterns, make predictions, and improve over time. And so this is another image that I created using AI, just to show you. And you can ask very specific things, and you get, this was not possible 2 years ago, and now we get so much better results, and imagine in 2, 5, 10 years, right? So we have the phase to implement these AI tools, you need data collection, and this is, well, there are many aspects in terms of sample size and how variable. Isabella said that she had not many examples of sows in a specific position or kneeling. So you need to have data, of course, for the computer to learn. So you develop these algorithms, and then you use, and this is the stage of inference, when you feed an image and you classify, or you detect an object in this image, or you are using microphones to detect animals that are coughing, and so forth. So, and then you come to the application in precision livestock farming or precision livestock management. And then there are many technologies. Some are already available commercially. Many are being researched. So you have many individuals across companies and across universities doing research, but using microphones or sound sensors, for example, to detect cough or sneeze or animals that are fighting. And then you have wearable sensors to detect position of animals or movement, and some other sensors, for example, non-contact vital sign monitoring, for example, ground vibration sensors. These are things that are being researched. And then computer vision, camera sensors, image, that's where I work mostly, as well as Isabella. Environmental sensors, then you are not focused on the animal now, but you want to monitor the environment in terms of temperature and gases and so forth. And then some other aspects here. Sometimes you want like cameras to be fixed in some positions. Sometimes you want cameras that you can bring with you. So there are these fixed and mobile sensors. What we see now, we are moving to systems that we integrate different sensors, because there is not one sensor that can give you everything, right? So you want to hear, you want to feel heat, you want to see movement, so, and animal identification. So I'm going to show you an example where we do this kind of integration. And then sensors for gases as well. Many different applications. For example, in ruminants, they are very interested in monitoring methane emissions, so you have this kind of sensors as well. So what are the interests? So early detection of disease is a very interesting topic, right? So we can use sensors to detect disease. And so we are still developing tools to detect disease earlier. But then another big question is, what do you do now, right? So because we know what we do when you find an individual that is sick, but what if I know that the individual is going to get sick? So that's another interesting question, what to do, right? In terms of separating this individual from the others, and what kind of treatment you're going to give. Monitoring welfare, precision feeding is being discussed here a lot. Environmental management, monitoring growth and body weight, as Isabella showed, and I'm going to show you as well. So there are many challenges, limitations. This is something that Isabella mentioned also. So many things that we see are still on the research phase, on an experimental farm where hygiene, cleanness, and availability of highly trained individuals is right there. That's another big leap when you think in terms of bringing this to commercial operations, right? But data, accuracy, generalization. So sometimes you develop an algorithm and it's working quite well, but when you move this to a different genetic line or a different nutrition feeding management, things don't work as well. So we need to calibrate and then retrain models and so forth. And then again, integration of sensors, what we call multimodality. So you have image, sounds, and different kind of data that you need to integrate to get better predictions. So in the end, we have this context, we say big data. We have different sources of information, sensor technologies, and then economics, environmental, weather data. We have farm management software, feeding data, surveys, and so forth. Okay? So the idea is how to go from this data, a massive amount of data, to decisions, data-driven decisions that can help you in the farm. So there are these two big groups of data analysis, and I'm going to show you some examples. One is like what we call batch analysis, where you collect data, and this is like we do in all kind of farm operations. We collect data over time, and then in genetic improvement, we do this a lot. So like every 6 months or 1 year, you are going to analyze all the data and estimate genetic merit of individuals to select the best ones. Or you want to benchmark, or you want to see what kind of feeder or bedding is working better. So this is what we call the batch analysis. So you accumulate and then analyze. And the other is in the context of precision farming management, that is real-time monitoring. So of course you're going to train the data using batch analysis, but once you have the algorithm, then the inferences are going to be on a real-time fashion. So here's an example. I'll just go quickly, but this was a project that we developed a few years ago, looking at transportation of pigs and losses, animals that die during transportation. So this was data from Iowa Select Farms, 1 year and a half or 3 years. Well, the whole project, we have 3 years of data, but for the transportation, I think was 1 year and a half. So we have these farms and sending finished pigs to the slaughterhouse. So we had like 26,000 shipments from 400 plus farms going to 2 plants, packing plants, 4.5 million hogs. Okay, so big data, and then we collect information from the, for example, the truck company, the driver, if it was the owner or employee, and then distance travel, density size, average size of pigs, and so forth. And the idea is to see what are the factors associated with mortality. So I'll just go over this, the details. I'll be glad to discuss this if you are interested, and there is also the paper. But just to show you that we found some interesting results, for example, that when the driver is the owner, you decrease, this is in the logistic scale, so you decrease the mortality, and then some other continuous variables we can see like graphically, distance traveled, interestingly, more distance. So with short distance, you increase mortality. So it seems that the stress of loading and unloading animals cannot be too close. And then when you have maybe from 100 to 200 kilometers, the mortality goes down. So we didn't have too long distance, so probably this is going to go up as you go too long. But for the distance that we had, this is what we found. And then temperature, humidity index, we found, of course, in the extremes, we have more mortality. And then body weight, of course, heavier animals, heavier mortality. This is for the two plants, and so forth. So this is like an interaction, a complex relationship of the interaction between wind speed and precipitation with mortality. But anyhow, so the idea is that you find factors that are important, and maybe you can develop optimization algorithms to decide how you're going to ship pigs to the slaughterhouse, depending on the size, depending on the temperature of the day, and the truck companies, and so forth. Another example with the same company, with the Iowa Select Farms. Now we are looking at movement of animals within farms. So we have the finishing, guilt development, nurses, and so forth. This is what we know from the shipments. So this is the number of shipments and the number of animals total going from, for example, south side to into finish, in nursery, and so forth. So our idea here was, what can we learn from this network in terms of the topology and which groups of farms are more susceptible, for example, if there is a disease outbreak. So farms that only send individuals out, farms that only receive, and animals that receive and send also. And then we look at the how, so we simulated disease here, and we are looking at the basic reproduction number, that is how many new infections you expected from each infected individual. So we simulate disease, highly contagious, intermediate, and low, and this would be the R0 scale from 0 to 100. When you start doing like the intervention that could be vaccination or cleaning barns and so forth, if you do at random, so these are many, many simulations with the confidence interval here. So of course you go to 0, but take some time. Only when you have 100% of the barns vaccinated or clean, that you go to 0. And this is if you use the network targeting the key barns to act. So you improve the system. So, but then let me move quickly to the precision farming technologies, some things that we are working on. So we are very interested. So there are many different sensors for motion, sound, gases, and so forth. We are very interested in image because we believe, well, because image gives a lot of information. So you can, if you have an accelerometer, you have the movement of the animal, but you don't know if this animal is interacting with another animal. You don't know the environment where this animal is, if it's wet or if it is, there are many other, a lot of information that you can get with images. And then of course, one camera monitoring multiple animals. There are many other advantages. Isabella mentioned these different camera technologies, the surveillance, RGB, color pictures, 3D, thermal, and so forth. So this was our early projects, body weight and some body or carcass information. Many years ago, we published this 5-6 years ago, was a project with PIC. We had 6+ animals with body weight and some ultrasound information as well. So we brought the animals to the scale, so we have body weight, and we took pictures top view with 3D, and we had also ultrasound for back fat and muscle depth. And I'm putting together a few projects here. But when we started this, deep learning was not as accessible yet, so we did some traditional machine learning analysis, but then with deep learning that I'm going to show you. So that's the pipeline that we develop, where you have the animals under the camera, but of course they can be touching the wall, or they are maybe not in a straight position. Whenever the animal gets good positions, we grab the pictures and process, and then like Isabella said, we look at volume, area, top view area, width, height, and so forth. And then we feed this in models that we compare different models. And then by 2020, we start using some deep learning methods, so we use deep learning as well. Deep learning, the advantage is that you don't need to pre-process this image, for example, segment, and then take these measurements and feed the model. The input is the image, and you train the model to give the prediction that you want. So just for you to have an idea, so different models, and this is the deep learning. This is the square of the correlation between observed and predicted. Quite good for body weight. Mean absolute error, 3 kilos, and these animals are 100, 120 kilos, so very good prediction. But not as good for muscle depth and back fat, so probably we need more data here. Another thing that we are very interested in is animal identification. I think this is a big bottleneck because it's not difficult for you to detect animals, to tell what these animals are doing, or maybe say, well, there is a sick animal. But we need to have the ID to be able to make an intervention, right? There are many different approaches that we use for animal identification, but our interest is to use camera as a possibility. So we've been working, for example, in host and cattle, where it's much easier because you have the coat color as a fingerprint. So you can easily detect animals and identify them. But this is not the same when you have animals with the same color, for example. And then we are using now the landscape of the body to determine, to ID. But this is quite good for dairy cattle or cattle in general, but pigs is not as easy because the cattle, you have the bones more exposed, and you have the key points that you can explore much easier than in pigs. So this is what we did in terms of with pigs. So we had data from a pen with 12 animals. These are we had 3 animals that had different color patterns, so we could easily tell apart ABC. Then 2 animals that were different from the others, but very similar between them. We are calling pairs. It's tough to distinguish between these 2, although you can tell them apart of the others. And then 7 animals white that you cannot tell them apart, okay? So we use these in a very, like a dirt situation to make things complicate. And what we have here is that using this deep learning algorithms is very easy for you to find animals and to track animals, okay? So we are using YOLO for detection and bot sort for tracking. But the problem is that, yes, you are tracking the animals, but if they have different similar color, you cannot tell them apart. So here's an illustration of this pen with the 3 animals that I can tell who they are, 2 animals that are different from the others. So if an animal like this moves, I can easily track, and I know which animal is this. So very simple. But now, if it is one of the white animals, you can still find this animal and track, but you don't know which animal is this. So in this case, we are using RFID. So whenever the animal comes to the feeder, we ID with the RFID, and now we recover this part and also trace forward this until these animals play or fight, and then you lose ID again. But then you keep tracking them until one goes to the feeder in this case, and then you recover the identification. So some results, I'm gonna skip this to give time for some questions. So just quick concluding remarks. Digital tools have been used a lot in research, not only to research to develop the tools, but sometimes the individual is interested on the feeding and then use sensors to measure something on the feeding experiment, right? So very useful in animal science overall. Very important in animal breeding because now you can measure some traits that we could not measure before, or you can measure better and more systematically, more objectively. And for example, if I can measure body weight every day, you can assess the growth curve of animals. You can select to change, for example, the parameter, the shape of the curves, right? So there are things that we can do in breeding now that we couldn't do before. And then management. This is the big challenge when you think in terms of bringing these tools to the commercial operations, the real farm conditions, where you need to think also in terms of return on investment. So there is the cost and so forth. So I mentioned breeding. And then what we are very interested in nowadays is the combination of sensors. Because, yeah, like I said, there is not a single sensor that's going to give everything we need. So in the end, it's going to be the integration. So this, I want to acknowledge the individuals that were directly involved in these papers these projects that I showed here, funding from USDA, data and collaboration with PIC and Select Farms. And then the identification work, Monica was a student in Valencia, and she came to work in my lab for 1 year. Thank you very much, and I'll be glad to answer any question.
Thank you so much, Dr. Guilherme Rosa, for the presentation. Are there any questions from the audience? Oh, there's one.
Guilherme, great work, great presentation as always. So looks like that those technologies are more, let's say, for the commercial conditions, from a commercial condition standpoint, more widely used in dairy world, let's say like that. So what do you think will be like the next step for the swine industry to have more of those technologies being implemented, especially like for growers, for nursery or finisher barns? There's a lot of potential things that we could do. But yeah, we don't have that yet.
Yeah, I think the cameras. What I feel is that like weight is body condition. Weight is something that the community wants, mostly for precision feeding, right? I don't think this is too far. I mean, that's. Algorithms are there. I think now it's more the logistics because you need to protect these cameras when you come to wash and the barn and so forth. And then heat detection, we see that is something that is very important. And then sow maternity, like for selection also. There are other things like looking at maternal ability, right? And yeah, it is true that dairy, especially dairy, is being using some of this technology more widely. But I don't know. Because, you know better than me, Edson. What is the next? What are the bottlenecks or the big challenges that we have now? But from the data science and technology, I think we are very close to have tools available to producers.
I would like to make a quick comment or follow up on that question, which is we often tend to treat our units of analysis are usually farms whenever we're discussing about disease occurrence, for example. But that is an oversimplification because the disease doesn't happen at the farm level; it happens on animals inside of a farm. So my question to you is associated to detecting specific animals that might be showing signs of disease, because if we could do that, then we could perhaps do some sort of intervention earlier. Or I was just talking to a producer in which he had two sows had abortions after 20-something weeks that the farm had not had any PRRS occurrence on the farm. So if we were able to detect those animals earlier, maybe we could remove those animals from the herd. And I don't know. My question to you is, are you aware of any work being done on that front?
Yeah, and that's what I mentioned in the beginning here, right? I think that these technologies are going to give us information that we don't know yet what to do. We need to research. Like if we know like an individual is, an animal is sick, we have a protocol in terms of which antibiotics, how many days to treat. But what if it's earlier detection, 1 week earlier? So I think it's a lot of research that's going to come for us to save in terms of cost and also chemical use. So that's another thing. But what you mentioned is remind me of something that is very important also, and you should be aware of this when you read a paper and they show you accuracy. We need to make sure that they are doing cross-validation, right? So you are training the model with a specific group of units and then assessing the model ability to predict in a new data. But quite often there is what we call data leakage, because the individual is working in a single farm, and then you have animals in the training and the test or validations, but they are in the same farm. So there is a covariance between, a dependence between these observations, and the accuracy that you are seeing is probably not the same when you go to a different farm, right? So you need to be careful when you are thinking in terms of how generalizable results are. So if you have multiple farms and then you have farms in and out of this training and testing, it's not always. Sometimes you have individuals with multiple measurements and people do cross-validation just at random, and so the same animal has observations in the training and testing. So it's very. There are these little things that we need to be aware. Otherwise, you get a over-optimistic result, and it's not where you are going to get in the practice.
Thank you for your response. Oh, okay. Last question from the audience.
So we already have commercially available camera learning technologies for counting and weighing that are available. Mm-hmm. In your research, what level of hardware expense or return on investment are you looking at when you're talking about the advanced or the movement to super intelligent AI?
Yeah. I'll tell you, I never did any kind of return on investment calculation with the pigs. We are working now on with beef cattle. We have some other projects, and there is one that is, we have now like a spin-off from the university that we are trying to commercialize, and then we are now running pilots to get this kind of information. What would be the return, and then calculate return on investment. So, but for the pigs, we are mostly on the research stage. I don't have this kind of information to give to you.
Thank you so much, Dr. Guilherme Rosa.
Okay.